You with Cape Talk.
It is the Friday edition of Views and News with Jacob Mushukwa. As promised, I did mention that the naked scientist, Dr. Chris Smith, will be joining us via Zoom so that he can answer all of your weird and wonderful questions. The naked scientist is with us right now. Dr. Chris Smith, good morning. How are you?
Morning, Jacob. I'm very good, thank you very much. I've had an exciting week. It's been a big week for space science. Are you a spacey? Do you like space stuff?
Barely like or know anything about space stuff, but tell me more.
Well, no. The reason is, you occasionally see a story which makes you sit up and go, "Wow, we can do this." And I had that sort of conversation this week because there's a paper just come out in one of the big journals where they reckon they've seen one of the first galaxies ever to exist in the universe. Now, this galaxy appeared about 13.5 billion years ago. Now, we used to think the universe was 13.5 billion years old. We now think it's about 13.8 billion years old. But this universe
Wow.
popped into existence just about 280, 300 million years after the Big Bang. The fact we can see back that far with the amazing James Webb Space Telescope and also see some of the chemicals that were being cooked up in the stars in that galaxy is
Wow.
absolutely extraordinary. And that's what's been published this week. So it sort of says the universe was getting its act together, getting organized and building stuff, including galaxies very, very fast, much, much sooner, probably in half the time than we originally thought that the universe was making galaxies and beginning to evolve to become what we ultimately see today. So it's an amazing sort of step forward in technology that's given us this glimpse back almost to the beginning of time itself. Just boggles my
Oh,
mind.
thanks for sharing that. That's amazing. It is mind-boggling. I totally understand why the Spaceys take it so seriously. I think that's great information to learn and know about. Maybe you might get me to start reading more about what's going on in our galaxy. Anyway, let's get into it. Dr. Chris Smith, my first question is from Vernon, and he says, following from the previous week's topic of magnetic field on Earth, what happens to a compass if it was taken to the moon or maybe Mars? Will it stop at a random point? Or will it spin continuously to seek north?
Well, the Earth has a magnetic field because inside the planet we have a molten core, which is a few thousand kilometers down under our feet, and it is turning. And we have a few theories about why a spinning molten iron core would cause a magnetic field, but it does. And it creates an effect similar to as though the planet had a giant bar magnet inside, where one end points upwards, one end points downwards, and it creates this magnetic field all around the planet. And when you put a magnet near another magnet, obviously the two fields interact and it causes your compass needle to deviate. Now, occasionally our magnetic field flips round, but as far as we can tell, all the time we have that molten magnetic core, it will create a magnetic field around the planet. The moon, on the other hand, is much, much smaller than the Earth. And the moon was formed because when the Earth was first forming itself, we think a giant collision happened between us and another planet, roughly the size of Mars, which ejected a lot of material from the surface of both of those planets into orbit around what is now the Earth. This coalesced to form the moon, which is why the moon is so big compared to our planet. Most moons are tiny little specks around their host planet. Ours is huge, and this is because it was formed as an offshoot of our own planet. But it's mainly crust material. And while the moon does still possibly have active volcanism and may well have had volcanoes going until we learned just recently, actually, until the time of the dinosaurs. Dinosaurs, if they'd had telescopes, might have been able to see some volcanic activity on the moon. The moon may still be volcanic. It doesn't have that iron core spinning inside it like the Earth does. Therefore, it has a much more randomly distributed set of magnetic fields, which don't produce that net effect like you would see on the Earth. So as you moved away from the Earth, your compass would point towards the Earth, and then eventually begin to wander. And when you got to the moon, you wouldn't be able to follow your compass to find the north and south pole of the moon. You'd have to do it another way because the moon doesn't have a field like we do. It doesn't have the same geology that the planet Earth does that gives us our magnetic field.
Doc, we've got a few voice notes that have come in as well. Let's give them a listen.
Good morning, everybody. I'm just trying to get in a quick question for Dr. Chris. I wonder if you could explain to us why the Higgs boson was awarded a Nobel Prize, because there was nothing original about it.
I don't feel remotely qualified to critique or otherwise the choice of the Nobel Prize Committee in awarding Peter Higgs the Nobel Prize for predicting the existence of the Higgs boson. This was confirmed more recently, but initially spotted in observations at the Large Hadron Collider at CERN back in about 2012. By colliding protons together and looking at the aftermath of those collisions, they were able to unpick from the patterns and showers of particles that were produced and invoke the existence of something called the Higgs field. Now, the insights of Peter Higgs, who died fairly recently, he lived in Edinburgh, was that a number of decades ago realised that there has to be a reason why, when we look at the material that the universe is made of, the fabric of the universe, why it has mass. In other words, when you put something on the scales in your kitchen, you can record a weight. Gravity is pulling that mass down for some reason. So particles have mass. Why do particles have mass? Well, the model we have of what makes up the world around us, the universe around us, had a missing link, a gap in it, which, while we could explain what things were made of, and that appeared to stand up to scrutiny, when we broke things apart, we could break atoms apart, and we could break the particles inside atoms apart, and we found subatomic particles, that all seemed to stack together, and it did appear to account for why things behaved the way they did, but it didn't account for mass. So there was a missing link. There was a hole in the puzzle. It's like you had a nice big picture of your jigsaw, but the piece in the middle where the face of the lead actor was, that was missing. And Peter Higgs formulated an idea that would explain, if you have this field pervading the universe, which particles can interact with, it would confer upon them the property of having mass. In other words, put them on the scales, they weigh something. This was a theory. And whilst it seemed to account for things, it had not been proved. And at CERN, by doing the right experiments in 2012, and then by refining those experiments subsequent to 2012, it appeared that Peter Higgs was right. And in his predictions, there is this notional field, the Higgs field, which the force is mediated by the Higgs boson, which is a force carrier, and this gives particles their mass. And this was regarded as an incredible insight, a great feat of physics, and he was conferred upon him the Nobel Prize for Physics in that particular year. And so I think it did provide us with an important part of the Standard Model, our understanding of how the fabric of the universe works. And for that reason, it was, I think, rightly recorded and rightly acknowledged.
All right, let's get into our next one. Earlier in the week, there was an interview about falling birth rates globally. At what point does a country reach a critical point where a population cannot recover? This one is from Solly in Athlone.
Hi, Solly. Well, it's not strictly true that there are falling birth rates across the planet. There are hotspots. Some places are seeing their populations of certain demographics fall, while other places are still seeing a rise. Overall, around the world, the rate of human population change is about 1%. In other words, if you add up all the countries and all the people reproducing, our human population is growing at an average of 1%. And you might say, well, that sounds pretty small. But actually, if you do the maths on this and use the compound interest formula to work out how much interest you'd have in your bank, you can work out that with a 1% rise in population, after about 72 years, so in other words, the lifetime of the average person listening to this program, you would have doubled the number of people on Earth. So 1% is still a very significant rate of growth, but it's not 1% because in some places it's far more than that. And if we look at places, and the African continent is destined to see a huge boom in population over the next decades. And if you look at where those populations are booming, you also see it is not a coincidence that many of the crises that have occurred with disease outbreaks map onto those same geographies. So in the wake of the Ebola crisis in the last 10 years, the countries that were most hard hit had the highest increases in population. 500% increases in population is not unusual. And with this very high population pressure, you get more conflict with nature, you get more conflict with people, you get higher population density, higher population movements. And as a result, it is a breeding ground for more problems that lead to the outbreaks of diseases. Now, in other countries, populations are declining or have stabilized, or certain demographics in those populations are actually shrinking. And if we look at the UK as an example, about 30 years ago, the average woman was having 2.4 children per person. So that was about the right replacement rate, because we know that at all ages there's an attrition in the population. So you need about 2.5 kids per couple, and that replaces the population, keeps it roughly stable. We're now in the, say, UK indigenous white population, that is about 1.2, that number. So the population is not replacing itself, it's actually in decline and will disappear. And many European countries are in a similar sort of situation. But the populations of the countries are not going down. The population of the UK has gone up by about 5 million people. And this is because there's been a big net immigration. People have come into the country, and they're coming from countries where there is a higher birth rate. So the planet as a whole, population rising, probably with quite significant consequences for the environment and so on, but populations of individual countries and particular demographics for various social reasons are in decline. And if you fall below about a magic 2.4 per person couple, you will end up with a declining population which will not sustain itself and will disappear.
It is Views and News with Jacob Mashukwa on Cape Talk, continuing our conversation with the naked scientist, Dr. Chris Smith. We are answering all your science-related questions. But for now, let's get into a quick call. Doc, are you there?
I certainly am. I'm watching you on Zoom, Jacob. I have to say, you've got a lot of energy, my man. It's really interesting because you sound really kind of calm. Well, you are really calm and collected, but for the listeners at home, Jacob is dancing on and jogging on the spot. You're doing, because a lot of people say when they are doing things that require focusing their mind, sometimes also keeping moving can be a really good way to actually keep themselves focused. Are you one of those people? Because you strike me as that you might be.
It sounds like I'm one of those people, Doc. I'm so glad you finally have given me a bit of an answer. My mom should be listening to this because she had a big problem with how my movements were when I was supposed to be concentrating in school.
Well, no, you're absolutely. I was just about to say precisely that, which is that we have kids these days who get labelled as ADHD and things like that, and yes, they want to move around, and they're doing it often to help themselves to focus. And we come along and say, sit still, don't do that. And in fact, it makes it worse because they are doing that because the parts of the brain that you need to lock onto and focus and concentrate are right next door to the same bits of the brain that help you move. So sometimes young people and older people will find that if they get moving, they can facilitate the concentration areas with the movements because the activity in the movement area spills over into the concentration area of the brain next door, and they get much better focus and they can concentrate better if they're doing something at the same time. And so in fact, there's a school of thought that says rather than tie kids down to a seat and make them sit still, you may be making them less likely to be able to concentrate. Sometimes letting people jig around and do their thing can be really, really good for their creativity. So good on you. That's probably what you're doing.
Thank you, Doc. I've been diagnosed by Dr. Chris Smith. Doc, let's get into a conversation with Alan now. He's got something to ask us. Alan, are you there?
Yeah, I'm here. How are you doing?
All right. How are you? Your question for Dr. Chris.
Does data have a weight? I mean, if you buy a hard drive and it's empty, then you throw this information, so it's full. You can't put any more information on it. There's a different weight to this thing.
Right,
wow,
well, this is a really good one. Does data weigh anything? The way you could look at this question is to say, well, if I bought a USB pen stick or pen drive and it was empty and then I loaded 1,000 songs onto it, would it weigh something different to when I started? The answer is both yes and no. So let me explain. The way that something like a hard disk or a USB pen drive stores information is digitally. It's storing a pattern of noughts and ones, which are in the transistors and how they are configured, how they're set, like switches. Now, normally, They would all have a sort of random mixture of noughts and ones or whatever, and there would be no difference in energy between them, and therefore there'd be no net weight difference. But you could argue, if I put every single one of them from a state of low energy to a state of high energy, so they all switch to ones, under those circumstances, I've added some energy to the device. I've added potential energy to the device, and therefore I could argue, because E, energy equals mc squared, mass and energy are interchangeable, that's Einstein's equation, I've added some energy, therefore I've added some mass. So if all of the transistors in the device were set to a high state from a low state, energy has net gone into the device, therefore the mass must have increased. But the amount of mass increase is going to be measured in tiny, tiny, tiny amounts that it would be almost impossible, I think, if not impossible, to actually measure. But you could argue, if you were really being really pernickety and you did that experiment, that yes, the data would have added some mass, but it's actually adding the energy to the device and flicking all the transistors to a high state that would do that. But under most circumstances, there's going to be a random pattern of noughts or a pattern of noughts and ones that are probably going to balance each other out. So no net increase in mass normally.
Ah, interesting question, and an even more interesting answer. I got another voice note for you, Doc.
Good morning. Question for Dr. Chris. This is regarding HPV virus. Since it is not curable, there's no vaccine for it, and then it is also antibiotics can't prevent it. And a cauliflower, which is caused by HPV, is highly infectious when coming into contact with other skin, or it can even affect the skin around where it has emerged. So upon touching the cauliflower, everyday people bath. So you can't get rid of the virus by washing your hands or even sanitizing using alcohol. So how is HPV even actually prevented?
Right.
Wow, good question.
This
Doc,
is
you have 1 minute.
Human papillomavirus, HPV, which causes warts and verrucas elsewhere on the body, but genital lesions if you catch it genitally, which is also, in that circumstance, associated with cancer because it can cause cervical cancer. But the good news is there's probably one of the most successful vaccines in the history of humankind, which has been used now and been used for more than 10 years and is very, very effective. So we can prevent human papillomavirus with the cervical cancer vaccine, and it protects men as well as women, but you have to use that vaccine before you come into contact with the virus. Otherwise, you're right, you need your immune system to kill off the virus, and once you've killed off the virus, you are clear for as long as it takes you to get reinfected, because it can then infect you again. So you do need to make sure you get in with the vaccine early. But yes, you have to be very careful not to transmit the virus from one place to another or one person to another. But washing your hands, because it needs to get in through a hole in the skin, washing the body parts should help to protect you. But the best thing to do is to not catch it in the first place.
Dr. Chris Smith, that's all the time we have. Thank you so much for it. Tune in again. The Naked Scientist will be back on the regular Friday Science Interaction. And that wraps up our time for today with the doc. For now, we're going to be going into a quick ad break and then news again.
You're with Cape Talk.